Okay, so I'm Arnaud Lauret. I'm the author of the design of web APIs. And you may also know me as the API handyman. I'm a senior API architect at Natixis, which is a French group providing banking and financial services. And my day job is basically helping IT and business people understand and create APIs. And when it comes to create APIs, it usually means helping people to design them. And so I do a lot of API design reviews. API design review is a vast topic covering many aspects from pure design concerns to cross-team API governance and everything in between. So if you want to learn more about that topic, I suggest that you look at my last year talk, the API design reviewer starter set that you can find on my blog. Today, I will focus on my journey to what I called the Augmented API Design Reviewer, which aims to make reviews more efficient, safer, and simpler. I will tell you why and how I automate part of API design reviews using the OpenAPI Specification and Spectral, or YAML, and JSON linter. So when people want to create a new API or modify an existing one, its design must be reviewed. To do so, I meet the API team, they explain me what they want to do, they send me the design, I analyze it in depth, and we discuss my feedback, they fix the design, and if needed, we cycle. An API design review has three purposes. First, ensuring that the identified needs are the real ones and ensuring that the design actually fulfills them. Second, ensuring that the design offers a good developer experience, that it is easy to understand, easy to use, and does not unduly expose internal implementation details. Third and last purpose, ensuring that the design has the same look and feel as all of our other APIs, and so making our APIs even more easy to use. And this is done by checking the design conforms to our API design guidelines. That sounds like a good plan, so what's the problem? Checking conformance to guidelines means checking that each property name is in lower camel case, checking that schema names does not end with technical suffix such as DTO, checking resource path structures, tracking non-evolvable array of strings, among dozens of other checks. Checking conformance of a small new API or a small modification in an existing API is done easily in a matter of minutes. But when there are dozens of them, minutes become hours, and there is a significant risk of oversight because I'm just an average human being with a very limited amount of concentration. And things get even worse when working on huge APIs. Hours can become days, and the question is not, will there be oversight when checking guidelines conformance, but how many? The problem with API design review is actually succeeding to spend the less possible time on these dumb checks and avoid oversight, and while spending as much time as possible on tasks actually requiring a human brain, like working on needs and developer experience. So how do we do that? By augmenting API design reviewers. Hopefully, we don't have to become machines or cyborgs to become faster and more accurate API design reviewers. All that is needed is a machine-readable API description format and a linter. So forget wiki pages and other spreadsheets. Use the OpenAPI specification to describe your APIs. The OpenAPI specification, formerly known as the Swagger specification, is a standard and programming language agnostic REST API description format. An OpenAPI document can be either in JSON or in YAML format, and it will describe API resources, operations, response bodies, and any other thing you need. To describe data, the OpenAPI specification relies on JSON schema, which allows to tell, for example, that the user object is composed of a mandatory ID, first name, last name, and also has an optional address, which type is defined by another JSON schema. So now that we have a machine-readable description of an API, we can analyze it with a linter. So instead of reinventing the wheel and creating my own linter, I use Stoplight Spectral, which is an open source linter that can analyze data such as OpenAPI documents, async API documents, Kubernetes configuration files, or any other JSON or YAML data. Linting an OpenAPI file with Spectral command line interface or CLI is quite simple. Open a terminal, type Spectral lint, followed by the OpenAPI file name. Spectral is able to detect some problems right out of the box without providing any information than the API description file itself. For each problem, you will get its location, line number, character index, its level, like warning or error, the rule name that detects the problem, and a human-friendly description of the problem. Spectral comes with a predefined set of rules specifically made to analyze OpenAPI documents, but your guidelines are probably not the same as the ones bundled in Spectral. And hopefully, you can design your own rules in order to check that an API design conforms to your guidelines. So a Spectral rule set is a YAML file. A basic rule set contains a rules property, and inside this rules property, you will describe rules. Each one will be identified by a name. And a basic rule is composed of 3 elements. The given property, which is a JSON path indicating where in the document this rule will be applied. The current value here targets the ID property of any reusable schema. The then property describes the controls to be done. Here, the control is applied on field type inside the element found by the given JSON path, and it consists in checking that the field type value belongs to an enumeration, which contains a single value, string. Enumeration is not the only available function. There are a few others that you can see here. And last but not least, property of a basic Spectral rules, a description that will tell humans what this rule checks. So basically, this rule that you see here checks that the ID property of any reusable schema is of type string. Let's run Spectral again with our rule set. Now Spectral tells us that on line 28 of the OpenAPI file, an ID is not of type string. Indeed, in the reusable user schema, the ID property is of type integer instead of string. When I did my first test, I was totally blown and totally convinced that Spectral was a must-have to secure and speed up my reviews. But what I show you looks quite simple when I use Spectral right here. So now let's talk about the real world beyond the hello world. Let's talk about how to actually build and then use Spectral rule set at scale. It would take a day-long workshop to describe all the functions, tips, and tricks I use to build Spectral rule set. As I don't have a day for this session, I will focus on the 2 most important matters that may not come obviously to our mind when using such tool. I will focus on how to design rule sets and how to be sure that they actually work. But still, while talking about these 2 topics, I may incidentally share some tips, but without going deep into details, so look for the tip alert red box on the slides. So just like an API, a Spectral rule set actually needs to be designed. You can just start from scratch and write random rules one after another. You need to think, you need to have a plan. So if you don't have already API design guidelines, write them, at least a minimal version that you will expand when needed. So look at my Lord of API design talks to learn more about that. Once that is done, you can start to express those guidelines as Spectral rules. But do not rush blindly. Just like when you represent jobs to be done as a REST API, you have to think twice. You must ensure that your rule design is actually relevant, user-friendly, and maintainable. To do so, you obviously have to think about rule names and descriptions, but choosing an adapted rule granularity, severity, and organization is even more essential. So let's talk about granularity first. If our guidelines tells that All responses are objects and not strings, for example. And get/whatever/plural name always returns a list of resources. And this list is represented as an object containing a required property, which name is items, and this property is an array containing the list of resources. And each item in this list must be an object and not a string or numbers. And when the response is a list, the return object may contain a page property that must provide the current page number and total number of pages. To check all that with Spectral, we could create a single rule named valid collection schema, telling that a list response must conform to our guidelines with a long but explicit description of what is expected. It would target schema of 200 responses, of get operation, on paths ending by a plural noun, thanks to some magic regex filter. And eventually, in the then clause, we could use the schema function that checks a data structures conforms to a given JSON schema. And we need to provide this function the JSON schema of the expected JSON schema of the response. There's a t-palette here, don't miss it. So what happens if we run Spectral with a rule set containing this rule on this OpenAPI file having a get/users returning an array of user? Spectral detects the problem. Great, but what is the problem? Is there a mistake on the pagination data, or is it something else like items which are on objects? We don't know. Maybe customizing the message to add problems path and error message may give us more clue about the problem. So what does it tell us? It tells us that user schema is missing a property named properties. That's not really useful unless you are an expert of your guidelines, your Spectral rules, JSON schema, and the OpenAPI specification. This rule is definitely too coarse-grained. So let's see what happens if we split it in smaller rules to test if the response is an object, if the list is encapsulated, and so on and so on. That's better. We know exactly what is the problem. The response should be an object, and the response should be a list, an encapsulated list. In my example, we only have seen warnings, but Spectral rules can have different severities, and here's how I use them. Error, that's an actual error. It must be fixed without any discussion, like a 204 no content returning data. Warning, it looks like an error, but it can be normal. Fix it if needed. For example, a post request body without any required property is not normal most of the time, but it can be normal sometimes. Information, it's a possible improvement. For example, hey, what about adding pagination or search filters to this get/whatever/plural name, which return a list? Hint, that's an element that needs to be discussed by the API team and the API design reviewer. For example, in my context, the use of content type other than application JSON that may require specific design and implementation because we don't want to have files going through our API gateway. That way, and especially using the hint level, I know where I have to focus my investigation and discussions. And finally, in order to be user-friendly, but most importantly, be maintainable, you have to organize your rules in various rule sets, just like you would organize functions in various libraries. Currently, I have 71 Spectral rules organized in 10 different rule sets. Rules are organized based on what they test. Each rule set can be used individually. And for example, if I want to check if each operation is covered by at least one OAuth2 scope, I will obviously use my security rule set. But if I want to use all my rule sets, I will use a main rule set that includes all the other ones, thanks to the extends property, which is a list of paths to other local or remote rule sets. As you can see, you can end with Many rule sets containing many rules, some of them being quite simple, but some of them being terribly complex, especially the one using regexes or JSON schema. But how to be sure that all of this actually works? By doing tests, as usual. And here's a summary of the various test strategy I used when I was learning Spectral. First, at the very beginning, I had a single rule set. So I created a single test OpenAPI file to check that all my rules were actually working. As the number of rules grew, it quickly became a nightmare. It was really hard to add new use case into the test OpenAPI files, and I was manually checking Spectral output to be sure that all expected errors were there. So I split my rule sets into smaller ones. And as said earlier, it was not only dictated by the need of just organizing rules, it was also done because it made testing easier. So I split rule set in small files, and I split the big OpenAPI files into different files, each one for each rule set. But even after that, it was still hard to add new use case into the different OpenAPI files, and it was still really painful to manually check the results of the test for each rule set. Hopefully, Spectral is available as a Node.js library. So I created Mocha unit test suites, and I used the Spectral library in them. I created one test file for each rule set, still using each OpenAPI file for them. But now I was programmatically checking that I get the expected results. That was better, and I even realized that some of my rules were actually not working at all. But even if it was better, using a single OpenAPI test file for each rule set and testing all rules of a rule set at once was too complex and prone to errors. That's why I got a level deeper in my testing strategy. I decided to test each rule in isolation with a dedicated input for each test. To do that, I tinkered with the result of the Spectral parser to only keep a specific rule active and all other rules being deactivated when running a test. I also managed to be able to use partial OpenAPI documents instead of complete ones, making writing tests easier. And after that, as the number of rules was growing, I was fearing to forget testing some of them. So I added checks to ensure that I had a test suite for each rule set, and inside each test suite, I checked that each rule has been used at least once. It's far from perfect, but it's working. After that, as my testing became more and more accurate, I realized that some rules were not working because the JSON path in my given clause were totally wrong. They were missing their targets, missing some of their targets, or hitting the wrong targets. So I got another level deeper. And instead of testing each rule as a whole, I did dedicated tests for the given clause to ensure that the JSON path actually hit what was expected and do not hit wrong targets. To do those tests, I tinkered again inside the result of the Spectral parser to get the given JSON path. Then I used the JSON path plus node library, which is used by Spectral under the hood. And I use it with some JSON input to check that the JSON path I was using were correct. The level of the given clause testing depends on the JSON path complexity. If there are no filters, I just check that I get what I expect with a simple example. But if there are filters, like you see here with regex and a very long path, I do check at every level. And I check that I get what is expected, and I also check that what is supposed to be ignored is ignored. After all these evolutions, writing tests for my rules and rule set became quite simple. I have some kind of spectral wrapper, and when I have a test suite, the higher level tells the rule set to load. Then inside, the other test suite name tells the wrapper which rule will be tested, and so it only activates this one. And after that, I usually have 4 basic tests I check that the given expression finds something. I check that the given expression ignores specific elements. And I check that I get errors when needed and I don't get errors when needed. And I have a final check, which consists in verifying that all rules have been tested. I have no more than 400 tests to check my 71 rules, and that really makes me confident. And so I don't need to double check what has been tested by my spectral rule set. And I can also design new rules very quickly. So let's sum up what we have seen about the design of spectral rule set. First, create your guidelines. Then, when you design your rule set, ensure user-friendliness and maintainability by designing rules, choosing adapted granularity, severity, and organizing them in various rule sets. And last but not least, do not forget to test your rules like you would test code. Once you have a minimum rule set, start to use it immediately. Do not wait to cover your rule guidelines. Using Spectral in your design and review process as soon as possible will help you to improve your rules and your Spectral skills. It may also give you a few new ideas about how to use Spectral in your review process. This happened to me, and now I use Spectral in 3 different ways. When I receive an API contract for review, I use the CLI to do a quick check and see how many problems there are. If I need to quickly go through all problems and jump from one to another, I open the file in Stoplight Studio. It's a GUI with both OpenAPI and Spectral support. I also use it when designing APIs, but that's another story. And to make my rules available in Studio, I just need to add a .spectral.yaml file in the project, and then reference my main rule set directly targeting my Git repository. And so the problems shown in Studio are the ones detected by my rule sets. And I just have to click on each problem to directly go to its source. But all this only works when there are not so many problems. If there are hundreds of them, and that happens when I do a full review of a very old and ugly APIs that was existing before we started to do API governance, the output of the CLI and the rendering in Studio is not really usable for me. I need to get started to know what are the different categories of problem in order to make a summarized review that will be the input of a design workshop in which I will explain the overall problems and point to various sections in our guidelines. Hopefully, the CLI can output its result as JSON. And so I pipe that JSON into JQ, which is a command line JSON processor that allows to do really crazy stuff like transforming spectral JSON output into a CSV file that I can import into a spreadsheet. So if you want to learn more about GQ and OpenAPI, check my blog. There is a series of posts about it. So once the CSV data is imported in a good old spreadsheet, I can easily sort, filter results, and get the stats I need for my workshop. Okay, this session was quite intense, and all this was only a brief summary of how I use Spectral. I use it now on all my reviews, and it really helps me to make more accurate, exhaustive, consistent, and faster reviews. And this is only the beginning. I will start to provide my rule sets to API designers and have many other ideas around this tool. So what should you retain from this session? First, using a machine-readable API description and an API description linter gives excellent results when reviewing and designing APIs, but you need to work on your rule set design and test them to actually get those excellent results. Also, obviously, a linter cannot fully replace human being when reviewing an API design. It will not tell you if the design is accurate to fulfill some needs. Sorry, but it will save your time to actually focus on that. It will save your time by making guidelines conformance check faster and reduce oversight. It will give you an overview of the stylistic quality of an API, and it will even give you some hints about things that should be discussed with API team. And we're done. Thank you very much for your attention. And now we may have some few minutes to a Q&A. So let me just check. the discussion. So, well, the first question, sorry, I speak French. Just scanning, there are many comments. If you ask question, do not hesitate to type them. Okay, there are some applause. Thank you very much. Okay, there is a question. If these rules are run on CI with time hit will compound and become noise in code linting. I don't get the question. Let me reread it. So the question is about integrating linting your API design into CI and generating a lot of noise. Maybe you can ignore rules. I don't think that you should ignore rules, and unfortunately, I have not yet experienced that. So maybe in another talk, I will talk more about it. But at the moment, I would suggest that keep all the rules and always check them, and maybe ignore hints. But I don't think so, because hints in my case really mean that you have to discuss. So in my opinion, for now, I would suggest to take care of everything. Okay, are you sharing some of your custom rule in open source? I'm working on that. So maybe in the near future, I may be able to do so. So I will post that on Twitter as soon as I can. So let's scan. We have still 1 minute, I think.